We're going to talk about factoring by grouping for polynomials with four terms. This is notes P.4 um, from the notes packet P.3 and P.4. And sometimes polynomials with more than three terms can be factored using a method called factoring by grouping. With four terms, you can try to group the first two terms and the last two terms by taking out the greatest common factor from each pair, or sometimes you can group the first three and leave the last one, or the first one and then group the last three. So that would be grouping 3, 1, or 1, 3. So we're going to try example 10. It gives three different examples where we can try factoring by grouping. So we see we have four terms. We are going to group the first two terms, and we're going to take out the greatest common factor from x squared y minus x squared z. The GCF here is x squared, so we're going to factor out the x squared. That leaves the factor y minus z. And then from the second two terms, we're going to factor those. We're going to take out the GCF, which would be negative 4. That will leave us with y minus z. And we can make sure that works. Negative 4 times y is negative 4y. Negative 4 times negative z is plus 4z. Then we see that we have a common factor between each of these two terms, which is y minus z. So essentially, we're factoring out the y minus z. So we have x squared minus 4 times y minus z. And whenever we're factoring, we're going to look at each of our factors and see if we factored completely. And when we look at that, we can see that x squared minus 4, is actually a difference of squares, and we can factor that further. So x squared minus 4 factors as x minus 2 times x plus 2, and then we still bring down the y minus z. So we have indeed factored completely. We have a bunch of, we've got factors that are multiplied together with no common factors inside the parentheses. Let's try the next example. We're going to try to factor these four terms. So it's a polynomial with four terms. 5x cubed minus 10x squared plus 3x minus 6. The first thing we're going to look for is, does there exist a GCF? Because that may make our life easier. And we should have looked for that in example A, but there wasn't a GCF. So I neglected to say that. In this case, there is no greatest common factor, so we can't do that. So we're going to try to let me erase that because we cannot take out a GCF. That would have helped us, but it's not there. So we are going to see if we can factor by grouping. So we're going to look at the first two terms and take out the GCF from those terms. So the GCF from 5x cubed minus 10x squared is 5x squared. From the first term, that leaves us with an x. And when we factor out a 5x squared from 10x squared, we get 2. And then we're going to look at the last two terms, which is plus 3x minus 6. The greatest common factor there is 3, leaving us with an x minus 2 factor. The x minus 2 factor is common to both of the terms, so we're going to be able to factor this by grouping. So we're going to have 5x squared plus 3 times the common factor, which is x minus 2. That's really what we're factoring out. We look at both of these terms. There is nothing else that we can do. Both of these factors are prime. Example C, 10C. We're going to try to factor 4x squared plus 4x plus 1 minus 25x squared. In this case, if we tried to factor the first two terms and the last two terms, we would not have a common factor between them. We can see that if we factor out a 4x here, we'd be left with x plus 1, and there's no way we're going to have an x in these terms, 1 minus 25y squared. So this one's a little bit tricky. A technique we can use is to look at if we factor this by grouping the first three terms. So where this is going to be grouping 3, 1, and we'll see if that works. So we're going to try to factor these first three terms, 4x squared plus 4x plus 1. If we look at these, we see that the first term is a perfect square, the last term is a perfect square, so perhaps this is a perfect square trinomial. That would be the case if this middle term is 2 times the square root of the first term times the square root of the last term. So it is indeed 2 times 2x times 1. So this is a perfect square trinomial, those first three terms. So we can factor the first three terms as 2x plus 1 quantity squared minus 25y squared. And now let's look at this and see if we can continue to factor. When I look at this, I have two terms. The first term is a perfect square. The last term is a perfect square. This is 5y quantity squared. So this I can factor as a difference of squares. So when I factor by difference of squares, that's the pattern that if I have a squared minus b squared, difference of two perfect squares, that factors as a plus b times a minus b. So here, this would factor as 2x plus 1 minus 5y, or plus 5y, we can do, it doesn't matter which one we do first. And we'd also have 2x plus y minus 5y. And there's really not much else we can do with this. There are no common factors that we can take out in either of the set of parentheses. So this is it. We factored it. 2x plus 1 plus 5y, 2x plus 1 minus 5y.